All right, everybody, we are about to go over a couple of examples where we are, as written up there, solving rational equations. Now, we have that one scrolling thing kind of above me. It says solve, evaluate, find, simplify. What else is there? Verify. So those are words that when you read directions for a problem, those words are kind of like your big clue trigger words. So if it says solve, it usually means you're finding what does x equal, or whatever other letter we might be using in our problem. So at the end, you know you're done if you have something like x equals blank or b equals blank or whatever letters in the problem. If it says to simplify, you're not going to have something like a letter equals a number. If it says simplify, you're just going to have a more cleaned up expression. In both cases, solving and simplifying, we usually end up needing to factor somewhere along the way. Okay, so it's really, really important that we're really good at all of the factoring methods. In the beginning of the school year, we did 5 classic factoring methods. Method number 1 we did was the greatest common factor. And I feel like we forget about greatest common factor. We always want to jump right to some double bubbles and have like this parenthesis and this parenthesis. But classic, greatest common factor, always look for that first. If your greatest common factor is a 2 or a -3 or an x, by pulling that out, you make the rest of the stuff cleaner and easier to look at. Factoring method number 2 that we did was grouping. And grouping makes factoring of things that are way more complex so much easier. You have to have at least 2 groups, and they have to have at least 2 terms each. However many terms they have in them, they all have to have the same number of terms. So you could have 3 groups of 3, 2 groups of 2, 2 groups of 3, 3 groups of 2, as long as they're all the same number of terms. The third method we did was the sum and difference. Both of those were applicable for this. Cube, sum and difference of cubes, and that's where SOAP came into play. Our fourth factoring method, so 3, I always remember 2, that means cubed 3, right? So number 3, cubes for a group. Takes 2 to make a group, right? Number 4 is a perfect square. That one is the difference of 2 squares. And the last method we did was really a combo method. Okay, it was really a combo method, and that was the AC method and grouping. So these are all still heavy into play while we do this unit on solving rational equations. So the first example we're going to do right now is we're going to solve the example 1 over, now I'm throwing some parentheses in here, b plus 1, plus I'm leaving some room between them so we could kind of jazz them up a bit, make it a little bit better for us. 1 over b minus 1, and then that equals 2 all over b squared minus 1. Now to warm up, before we started recording, we just had a quick little chat about factoring, and we reviewed a couple little concepts here. Now, when you add fractions, I cannot stress this enough. You do not just like caveman style, like I do math and like add the tops and add the bottoms. That is not, no one ever showed you that. No one ever showed you that. No one ever showed you that. You do not do that. When we add fractions, no matter what, whether we're in 4th grade or if we're in college, does not matter. When you're adding fractions, you gotta have a blank. What do we need to have in order to add fractions? We need to have a
Least common denominator.
right, a common denominator. Does it have to be the least common denominator? No, it doesn't have to be the least common. It could be any common. But let's be serious. It's just a lot easier if it's the least common, because who wants to deal with numbers that are bigger than they need to be? So we strive for the least common, but sometimes we settle for common. Now, we could look at this a couple ways, and we prepped for this at the very beginning of this unit. So we're going to analyze this in 2 ways over here. Question, Isa or Jabari? I see a couple hands up, so I want to make sure.
Sorry.
Sorry, Isa, you have one though, right? Go ahead.
And I pressed on accident.
Oh, okay. So method number one, more classic method, right? So what we want to do is just classic find the least common denominator, and we need to break down and look at our factors. B plus 1 is linear. That means it's to the first power, b to the 1, right? That's already linear, and that means it's already a linear factor, okay? A lot of the times when we say factor in Algebra 2 and beyond, the word before it we know as like an adjective describing a noun. The word before it, linear, is describing the type of factor that we're dealing with. So if we have a linear factor like b plus 1, we're good. That's prime. You can't factor that any further. Once your degree of a polynomial, right? These denominators are all little baby polynomials, b plus 1, b minus 1, b squared minus 1. Once the degree of the polynomial in your denominator is bigger than 1, you got to check if it's factorable. If it's not and it's prime, then you don't have to factor it. An example of one that's prime, this is a little sloppy, but from just a minute ago, right? We factored this just a few minutes ago before I started recording, and we got that 6x plus 5. Oops, I didn't write always plus. And we got that 36x squared minus 30x plus 25. These are actually both prime. This is a prime linear factor. And this right here is a prime quadratic factor. It doesn't factor any further. So the quadratic trinomial from a SOAP problem or a sum or difference of cubes problem doesn't factor. It looks so good, like it might, right? Like these numbers are so related and you're like, yeah, that factors. I promise you, it doesn't factor. It's an illusion, right? Prime, factors. This over here, though, we could factor this. Factored already. How does b squared minus 1 factor? Can anyone tell me? And what is the name of that type of expression? Or what is the name? So you could either tell me what it's called, tell me how to factor it, or tell me both. So what do you got? Go ahead, Paige.
It's a quadratic binomial.
It is a quadratic binomial, and it even has another fancy name, DOTS.
Dots?
Well, what do they stand for?
Difference of two squares.
Yes, Adriana, good.
Oh, yeah.
Difference of two squares. Paige is still right. The bigger umbrella that it falls under is a quadratic binomial. A smaller umbrella under that is that it's a difference of two squares. It's just a little bit more specific. And Paige, how do you factor b squared minus 1? I think Dylan factored one like that for us just a minute ago.
It is b minus 1, b plus 1.
Good. And that's exactly what Dylan did for us just a minute ago on a different example. What is the, if you answer this correctly, ladies, gentlemen, I will be so happy. But what is the name of what b plus 1 is in relation to b minus 1? C word.
Conjugate.
I knew Jabari was coming in with the conjugates. I think, Jabari, you're the conjugate king. I think like you usually are the one that comes swooping in with that conjugate answer. Yes, these are conjugates of each other. It's just such a good word. I feel like it's like you could really impress your future professors one day, okay? So here everything is factored. Looking at the denominators, b plus 1s and b minus 1s are all we have. Remember I compared this to kids and Skittles, and that you want to make your kids all happy because they're all jealous of what each other have. So you look at their denominators and you're like, what do I have to do to make sure all my kids have the same stuff? But I'm on a budget, so I got to give them, the bare minimum, but make sure they all have the same, okay? What does this fraction need on top and bottom so it isn't jealous of its siblings? What does this fraction need? Hashara, Manuel, Sol, Natalie, Melvin. Anybody know? What do I have to put? Multiply on top and on bottom so that this fraction is not jealous of all the other fractions.
B minus 1.
It needs a b minus 1. Thank you. B minus 1 and a b minus 1. All right. What did you do on bottom? You do on top. We're one step closer to where we're going. Remember, this was your homework. You should have it done already. And if you didn't do the homework, or even if you did and you made a mistake, you want to make sure you make those corrections and then you resubmit after we go over it, okay? Ask questions if you are confused. Here, we
You
got.
want to put it? You want us to resubmit it back on the?
So
the
yeah, you
chart?
just add another picture. I'll see a timestamp on the classroom of like, oh, this one Jabari uploaded at the beginning of class. You know, later in the middle or at the end of class, Jabari uploaded this one. This is his corrections. So Jabari not only did the homework, but Jabari made sure he fixed his homework. So Jabari is double fantastic.
Okay.
All right. What do I have to put on top? And you might have done it slightly differently. That doesn't mean you have to upload it. You know, as long as it's pretty good and you got the right answer and it looks almost the same, then you're good. What about this one? What does this need on the numerator and denominator? So this problem is happy and not jealous of its siblings. What does this one need? Sean, Asaya, Tahani, Ella. What do we need? Justin. Anybody? Shout it out. Anybody could shout it out. Go ahead.
B plus 1.
Yes, B plus 1. So we're all making sure we have that copied right over there. So now this B squared minus 1, I basically replaced it with its factored form. So now this is my new equation, all right? I'm going to rewrite this a little bit. Over here, I have 1 over B plus 1, B minus 1, plus another 1 over B plus 1, B minus 1. Those have a common denominator, and they're on the same side of the equal sign. I could just combine them. Oh, I don't have 1 over. Who am I kidding? What's on top of this one? What am I babbling about? What's the numerator of my first fraction? Silly me.
B minus 1.
Yeah. Wow, you guys almost let me say the wrong thing. B minus 1. And over here, what's my numerator of this fraction?
B plus 1.
Good. Now, if they have a common denominator, I can add them. So this step, some of you maybe skip. Everyone's a little bit different with the amount of work that they show. I'm just going to start a little bit more to the left. So once they have a common denominator, we could write that denominator just one time, B plus 1 and B minus 1. And we can add or subtract those numerators as indicated. So my numerator, I'm going to kind of do 2 lines over here so I could fit 2 steps. I'm going to have that B minus 1 plus that B plus 1. Okay. And I have both of those on top. And underneath it, like I said, I'm just trying to save a little space, copying down, you know, line by line. The line underneath that, I'll actually combine them. So this B minus 1, it's right here. And then the B plus 1 above that is right over here. What happens when I add those together, Justin? What do I get when
They cancel out.
Totally cancel out everything? Like there's 0 left?
Not the B's, just the ones.
The ones do cancel out. Good. They become a 0, a -1, and a +1. And what about the B's? What do they become?
Does it become or 2B or
2B. Good. What's the other answer you think people put by mistake?
B squared?
Yes. And when would it be B squared? B
'Cause
plus?
it's not multiplication.
Good. It would be B times B. And you caught yourself. I feel like you almost wanted to go there, right? And you just hesitated. You caught it yourself?
Yeah.
Good. All right. So Justin, that was good. All right. So guys, you want to watch out. B times B is B squared. Okay. B by B, B squared. Think of the dimensions of like a 2x4 at the store, right? A 2x4 is the cross section of the side of a piece of wood at the store, at like Lowe's or something, 2 inches by 4 inches. And that means that that piece of wood has like 8 square inches on its side. So square inches, because it makes up an area. B times B by B with the X, okay? Now that's just the left side, and that still equals this over here. A 2 on top, and it still has B plus 1 and a B minus 1 on bottom. What can we do next? We're solving along. So we started here. We went down to this step here. This was step 2. Step 3 is the one I'm on over here. 3 and 4 kind of combined into one step. So where am I going from here into my next step?
You would like dismiss the denominator.
Ooh,
I don't know if
dismiss.
that makes sense.
No, I
And
understand.
then you would do 2b equals 2, and then you would divide by 2, which would give you b equals 1.
All right. So everyone, I hope you heard what Paige said. I like the word that she used, dismiss. She's like, dismiss the denominator. And yeah, she's right. You can dismiss the denominator. This over here is called using the 1-to-1 property. Because they both have that same denominator, you could kind of ignore it because you're comparing numerators to numerators. It's like the expression, compare apples to apples, you know? So 1-to-1 property. So she's dismissing or ignoring that denominator, and she's saying 2b over something equals 2 over that same thing. Well, that means 2b has to equal 2, right? So she said 2b has to be 2. And then to finish it up, solving for b, she divides both sides by 2, and she gets that b equals 1. Now that might be fine and dandy over here, but what do we have to remember to do for these problems? Because we have division and because we have these variables in our denominator, we have to remember to do what in our problem?
Restrictions.
Restrictions, good. So if you look all over the place at this problem, okay? Now the first thing we did, step one, we factored that denominator. Step 2, we found a common denominator. Step 3, we took our numerators and we added them up. Step 4, we combined like terms. Step 5, we dismissed our denominators. Step 6, we got what b equals. Now we got to state our restrictions. What are the restrictions about b? Looking at your denominators, we're not allowed to divide by 0. So we go to all the denominators anywhere in the problem. You look at your denominators and you say, well, according to my denominators, b could not equal certain numbers. So what do you got for me, Kennedy?
Like, would b can't be -1?
B can't be -1. Is there anything else b can't be?
Positive 1? Positive.
Exactly. Yeah, both. +1, negative and +1. Okay. Amelia, Paige, Kennedy, all of you, thank you. B cannot equal -1 or +1. Uh-oh. What did I get for my restriction? And what did I get for my answer? Restriction, answer. So what does that tell you about my final conclusion?
That's no solution.
You got it. That's it. No solution. No solution. That's it. Did anybody get no solution for this one all on their own? Did anybody
Yeah,
get?
I got like the restrictions down, but I didn't put no solution.
Okay. But
yeah.
like all the evidence on your paper was pointing in that direction.
Mhm.
Good. All right. So that is the end of this very first example. First problem that we did right over here. We were solving this quadratic equation, and after all that work, we just get no solution. All right. So if you understand, thumbs up. If you don't understand, you need help, thumbs down. And we will take it from there.